Hey guys, in this video I'm going to be showing you how to create a program that will parse this students.txt file right here, and it's just going to print out some information about these students. So it'll print out who the valedictorian is, it'll print out the students that are on the honor roll, and it'll print out the students that are failing. And we're going to write this program in C++, and I'm going to try and use some C++ 11 features, but this video isn't really about that. It's more about showing you really walking you through how to make a simple program like this. Alright, and then I'm going to use Xcode as the IDE. That's pretty standard on OS X, but if you're on Windows or Linux, you can use whatever you want. Qt Creator is good for Linux or OS X, I guess, and I'd recommend Visual Studio on Windows. That's a really nice IDE. But anyways, let's go ahead and create this project. So I'm just going to go ahead and open up Xcode right here and create a new project. So we want it to be a command line tool under OS X application, and we want it to be command line tool. Make sure the language is C++, not Objective-C, any of this core foundation stuff, or C. It's got to be C++. And I'm going to make the name of this program Student Information Analyzer. And I'll just put it in that directory right there. Okay, now we're not going to really mess with any of this information yet. I don't even think we're really going to need to mess with it at all. So just go on and click on main.cpp, and here we go. So you can go ahead and delete this hello world code right there. We're not going to be needing that. But the first thing that we're going to want to do is go ahead and create two new classes. So the first class that we're going to want to create is going to be called just student. And it's going to store all the information about a student. And then we're also going to want to create another file, another C++ class, which will be called student list. And I think the first time that I actually created, or when I created the student class, I actually hit Command N, which brings up the new file window instead of navigating through all those menus. That's what I did, just so you know. And yeah, so now let's talk about what information we're going to need in this student class right here. So let me just show you this student's text file a little bit more in depth. Alright, so here is the text file that we'll be supplied with, and inside of here is obviously just a list of students. Now we have the first name, the last name, the student ID, which we're really not going to need for this project, and we also need the grade point average, and it's on a scale between 0 and 100. And as you can see, it is there are decimals in it, so we're going to need to store this in a double or a float or something like that. All right. So let's go ahead and create the student class right here. So I'm in the header file. So I'm just going to say create a new class called student, and we're going to first create the constructor. So we're going to say like this, and the constructor is just going to take a std string. Well, I'll say std string and std string, and it's just going to be called student information. And ultimately, what this student information is going to be is just this line of text right here, a single line in this text file. All right. Now, since we're using std string, we should go ahead and include that up here. So we're going to say string. And we do not need IfStream. We're not going to be printing anything out to see out or reading anything in from the console or anything like that in this class. Yeah. Alright, so, and then we're going to worry about our private numbers right now. So we're going to need to store all of this information. So we need the first name, the last name, the ID, and the GPA. So the first name and the last name, those are both going to be strings, obviously. So we're going to say first name Man, I just love making that S in string capitalized. And then we need the ID, and then we also need the GPA, which will make a double. And as you can see, ID is orange, and the reason that ID is orange is because, well, it's thinking that, well, it's using Objective-C syntax highlighting for this header file right here, so we're going to have to go ahead and change that. So I think it's under Editor, yep, and then syntax coloring, and we're going to want to change that to C++ instead of Objective-C. And we should do the same for this student list.h header file. So go to Editor, syntax coloring, and C++. Alright. So yeah, so these are all the members that we're going to need for this class. Now, I guess another thing that I should mention is that you're probably wondering why I didn't just throw a using statement up here. Why didn't I just say using namespace std? That would save us from putting, std : in front of all these things. Well, it's really not a good idea to ever put using statements in header files, because let's say that someone else included your header file and then they were running into some conflict. So let's say they included your header file in one of their classes, and then let's say in another header file that they're including has some class called string, which there never would be, but let's say they had something else in the standard library that that isn't so obvious as string, like, I don't know, maybe an exception or something like that. They just had something defined that's in the standard namespace that isn't the standard namespace one. So someone else made their own class called exception or whatever. And since you have this using namespace thing in the header file, if they included both of those headers, so your header file, this student.h, and another header file that defined exception, there would be an error, and there would be nothing that the person could do to fix that, since this is in your header file. So that's why you should never have using statements inside of header files. You can put them in code files all you want, and I encourage you to, because it just makes it easier, but never put using statements in header files. Alright, so now let's go ahead and, well, actually, before we start writing the constructor, let's go ahead and come up with the other methods that we're going to need. So we're not going to have any setter functions for these values. We will have getters, though. The reason that we're not going to have setters is because we're not going to have any functions to allow you to rewrite the text file, so there's really no reason for you to modify these values at all. Alright, so we do have all the getters here, but we're going to also create another getter, which is just going to be called get name. And get name is just going to return first name plus last name. Alright. Not sure why there's an error here. I guess it just didn't update yet. Alright, so we can just ignore that right now. So yeah, now let's go ahead and start writing all the code behind these methods right here. So the first thing that we're going to do is go ahead and write the constructor. So we're just going to say student : student, and it takes an std string called student information. And before we go any further, let me just go ahead and throw that using statement up here so that we don't have to type out std all the time. And I'll actually remove it from there. Alright, so there are a bunch of different ways that we could go about taking this student information and putting it into these variables, but I think the best way to do it is to use a string stream. So in case you forgot what the student information is going to be, it is just a single line in this students.txt file right here. So what we're going to do is create a string stream, and in order to use the string stream class, we're going to have to include the SStream rather header. So now let's go ahead and create a string stream, and we'll just call this student stream, and we'll create a string stream from that student information. Yeah, now this is really easy. Now we just have to say student stream, that operator right there, and then just first name, last name, ID, GPA. And let me just make sure that's the correct order. So first we have the first name, the last name, the ID, and then the GPA. Alright, so that was pretty simple. And that's actually all that we need to do in the constructor. Well, at least I'm pretty sure. Well, let me just think about it for a second. Yeah, so that's all we need to have in the constructor. So now let's go ahead and create our getters. Okay, so now we have all these getters done, and that's really all that we need to do. So let's go back to the, well actually, what we should do first, before we try implementing or creating the student list class, we should go ahead and test out our student class. So we're going to go ahead right here and just say include student.h. And in case you're wondering when you use quotes and when you use angle brackets, let me just say, quotes are used when the header file that you're using is in your project or something like that, or let's say you're using like a third-party library and you're using their header files, then you would use the quotes. But if you're using some system header file or some something in the standard library like IfStream or string or something like that, then you're going to want to use the angle brackets. So an example of a system header file would be like if you're doing something with, I don't even remember what's in here. I just remember using this a lot when I was doing C programming. If you're going to want to use some system header file, like because Unix standard, I think that's what it stands for, then you would use the angle brackets as well. Alright, so we need to include student.h. Yeah, so that we can go ahead and test out our student class, make sure that all works properly. So we're going to say student, I guess we'll just say student, and then what we need to do is just give it a string of a student. So basically what that would be is just this. So I'll just go ahead and copy the first line in this text file like that, and then we're just going to go ahead and print out all the information. So we'll just say name. Okay, yeah, so as you can see, it's giving me some errors right here, and the reason that it is giving me some errors is because I didn't put a using statement for namespace std. So let's go ahead and do that. So using namespace std. And remember, the reason that it's okay to put this using statement up here is because we're in a code file, and it looks like I have two sets of parentheses right there. Alright, so let me just go ahead and run this and make sure that it all works. So yeah, got John Appleseed, ID is 4325, and the GPA is 89.2. Alright, so yeah, everything works alright in the student class. So let's go ahead and create the student list class. And let me go ahead and delete that. There's really no reason for that to be there. This header file is going to be pretty small. Alright, so we're going to say class student list. It's not going to inherit from anything. And then let's go ahead and create the constructor. So student list. And we're going to be using a string. We don't need IOStream. Again, we're not going to be printing anything out or reading anything in. And, well, at least not from the standard input-output. Yeah, so now what we need to do is, for our student list, it needs to take the path to our student text file. Because remember, we're going to be reading all the student information from this text file. So this argument just needs to be a std string since there's no using statement, and yeah, and this is just going to be I guess I'll just call it file path. Alright, and then our private members, we're going to want to have a vector of all the students. So we're going to need to include two things right here. We're going to need to include vector, and we're going to need to include the student.h. because that's where a student lives, because it needs to know all about the student class if we want to have a vector of them. Alright, and then the three methods that we're going to have a method that returns the valedictorian. So we're going to have get valedictorian. I think that's how you spell it. If not, I am sorry. We're going to have another method that returns a vector of students who are on honor roll. So we're going to say get honor roll students. And we're going to have another method called get failing students. Alright. Oh yeah, I forgot that std. Okay, now let's go ahead and implement all of these methods. So, the first thing that we're going to want to do is just go ahead and implement the constructor. So, well, actually it's student list. Student list, it takes a string, which is file path, And again, we're going to want to put that using statement up here. All right, so, since we're going to be reading from a file, we're going to have to go ahead and create a file stream. So we need to go back into the header file and include IfStream. That just stands for file stream. Alright, so we could construct an IfStream object, but we're not going to be doing any output. We're not going to be writing back to the file at all. So we're just going to create an IfStream, which is an in file stream. So we're only going to be reading from the file. And then we'll just call this student file. And then all that we need to give it is the path to that student file. Alright, so now what we're going to do is read every single line in the file in, but one at a time. So what we're going to do is read in a line from the file and then parse the student at that line, and then read the next file and so on, or read the next line and so on. Alright, so we're just going to go ahead and create a string for the line contents, and then we want to keep looping until we reach the end of the file. So there's actually a way to test for that in C++, so we can just say student file.eof, which stands for end of file. So while we are not at the end of the file, keep looping. Alright, so the first thing that we need to do inside this loop is actually read the file from, or read the line from the file. So we can do that with the getLine method, and it takes 2 arguments, at least the one that we're going to be using. It takes 2 arguments, and we need to give it the file that we're reading from and the string that we want to read that line into. Alright. So then what we need to do is actually parse that line as a student. So we're going to say student s, and then we just need to give it the student information, which is, in our case, just the line contents. And then what we can do is just push that new student back onto our vector. So we can say students, which is a vector, as you can see right there, and then just push back. And we'll push back that new student. Alright, so then once we get out of this while loop right here, we will have read the entire contents of the file, so we don't need to do any more reading or anything like that. So let's just go ahead and close that student file. And closing it allows other applications to read from it, so yeah, there's really no good reason not to close it. Of course, when this goes out of scope, when this IfStream goes out of scope, it will close, but I think it's good practice to just close it explicitly like this. You know, there's no reason to wait around until we get to the end of the method. We could stop right here and go on and implement these other methods without doing anything else. However, I think it's much easier if we sort all of these students by their GPA. That will make it much easier on ourselves. Before we can actually sort them, we have to include the algorithm header file. So we're going to have to say include algorithm, like that. And now we can use that sort method. So let's just go ahead and call that sort function. So sort, and the sort that we're going to be using takes 3 arguments. So the first argument is going to be an iterator that points to the beginning of what we want to sort. So we want to sort the entire vector of students. So we're going to say students.begin. And the next argument is going to be an iterator that points to the end of where we want to sort. And again, we want to sort the entire vector, so we're just going to point to the very end. So we'll say students.end. And then the third argument is a function that will compare two of the objects that we're sorting. So this sort method obviously has no idea what a student object is, since we just created it. There's no way that the C++ standard could possibly know how to compare 2 student objects. They want us to give them a method to compare it for them. So there are a couple different ways we could do this. One way is to just go ahead and create another method down here and then just give them the name of that, but I think a much easier way is to just do it inline with a lambda expression. Lambdas were actually added in C++ 11, so if you're using like C++ 98 or 03 or something like that, you're actually not going to be able to use lambdas, but if you don't have a compiler that supports C++ 11, I don't know what's wrong. pretty much every compiler that I know of right now supports C++11. If you're on like Ming, if you're on an old version of Ming or GCC or something like that, just go ahead and upgrade it. There's no reason not to. All right, so anyways, this is the syntax for creating a lambda. So you're just going to want to do 2 brackets like that, and then you're going to want to, I don't know what I did there, and then you're going to want to put 2 parentheses, and then in these parentheses just list your arguments like any other function. So it's going to take two students, so we'll just say student S1 and student S2, and I'm going to actually pass these by reference so that it doesn't have to pass around the entire student object. In our case, the student object is small enough where it doesn't really matter. But if we had some huge class that we were trying to sort, like, I don't know what that would be, but if we were trying to sort some class that was like, I don't know, a megabyte or something like that, you're definitely going to want to pass them by reference. And then now that we have our arguments, we can just go ahead and put 2 brackets like that, or curly braces, however you pronounce those. And then we can just put our code inside of there. Now, if I was using a smaller font, I'd probably put this entire thing just on 1 line, but I'm not, so I'll write it like this. And all that this method needs to do is just return true if the first argument is less than the second argument. And if they're equal, it has to return false, or if this one is greater than the second argument, then it has to return false. So we're just going to say s1 dot get GPA is less than s2 dot get GPA. All right, and we can't use less than or equal right here because remember, if they are the same, then that means we have to return. Oops, my bad, forgot the return. But if they're the same, we have to return false, or else we're going to have some issues right here. So yeah, it'll actually throw an exception if these are equal and you return true. That's not good. You're not going to want to do that. Now let's try and think about this a little bit more. So if I did where S1 is less than S2, then it's going to sort it in order. So that means that the students with the lowest GPA will be at the beginning, and the students with the highest GPA will be at the very end. Now, for some of you, that might make perfect sense, but for me, I would rather have it the exact opposite, so that the students with the highest GPA are at the beginning of the vector, and the students with the lowest GPA are at the end of the vector. So instead of doing less than right here, we're actually going to change this to greater than. Now, just because I'm doing this, just because I'm changing it to greater than instead of less than, does not mean that I make it greater than or equal to. You never return true if these 2 arguments are equal. Remember, I just said that you'll get an exception thrown if that happens. All right, so there is our sort method, and I think that's all that we need to do for this method. And yeah, so that's all that we need for this constructor. So now let's go ahead and test this out to make sure that this sort works and that this parse works and everything like that. All right, so right now this students vector is private, so there's no way for us to really test this in an external function. Now, of course, we could write some helper function inside of here that that returns this or something like that, but for this, there's no reason to do that. We can just go ahead and comment this out right here so that the students vector is now public. And remember that we have this commented out right here. We're going to have to uncomment this later because we don't want the students vector to actually be public. We're just making it public so that we can test stuff out. So let's go back to main.cpp, and we are going to go ahead and include student list. So we'll say include student list. All right, and I'm going to put these 3 lines of code into a function. So I'm going to say void print student info. Actually, just print student is fine. And it's just going to take a student s like that. Actually, I'll have to change this to say student. Now what we're going to want to do is, instead of constructing a student like this, we're going to want to construct a student list object. So we'll say list. And now what we need to do is give it the path to this text file right here. And I do not remember exactly how the file system on OS X is laid out, so I don't know off the top of my head the path to this file. So what I'm going to do is just minimize this and right click on this and go to get info and see where this is. So it just says where right here, and that's the path to it. So now I'll just go back into Xcode and paste it in there like that. And then this is just the location of where that text file is. It's not actually the path to the text file. We need to give it the path to the text file, so we need to include the name of the text file in there, and I think the name of it is just students.txt. Yeah, so students.txt. Alright, and then all that we're going to do is just iterate through every single one of the students and just print them out. So we're going to say for student s in list.students, and then we'll just call print student s. And if you haven't seen this syntax before, this is actually called an enhanced for loop. And if you're familiar with other languages, this is similar to the for each in C#, yeah, and in Java, this is called an enhanced for loop. I'm pretty sure it's actually the exact same syntax too in Java. I think Objective-C has a for each too, yeah, and finally C++11 they added in a for each loop. They call it a range-based for loop, but essentially it's the exact same thing as doing this. So if I said int I equals 0, while I is less than list.students.size, and then if we just did yeah, so these two things are equivalent, and I mean, if you wanted to, I could show you the third equivalent, which is using an iterator, but I really don't want to write all that. So yeah, just know that this is the exact same thing. As you can see, it's obviously much easier to just write this. Okay, so let's just go ahead and run this and make sure that it parses this correctly. And remember, this should be in sorted order by GPA, so the student with the highest GPA should be printed out first. Oh, yeah, as you can see, it did work, but let me just go ahead and change something around here because that's really hard to read. Let me just throw a new line in right there. Alright, yeah, now you can see all the students much easier, so. Yeah, so we got Goody Two Shoes at the top right here with a 99.6 average, and we've got Old Greg down here at the bottom with a 49.2 average. Alright, so let's go ahead and write the rest of these functions for the student list. So we can make this private once again. And yeah, so now what we need to do is write the getValedictorian function, and that's super easy to write. So we can just go back here and say this returns a student. It's in the student list class, and it's called getValedictorian. And all that we need to do is just return the student at index 0. And the reason that we have to do that is because it's already in sorted order, so there's no reason for us to go through this entire vector of students trying to find the one with the highest average. That student will just be at the very beginning. So we can just say return students dot at 0. But we are not done, because what if there are no students? What if the text file is empty that the user supplied us? When they call getValedictorian, it's just going to throw an out of range exception. Now, we could just be fine with that, but honestly, I would rather have it throw one of our own exceptions. So what we're going to do is just go ahead and check to make sure that the student's size is greater than 0. Well, actually, what we'll do is we'll say if it is 0, then we want to throw an exception. But what we're going to have to do is actually create our own exception class. And believe it or not, this is much easier than you might think. All we have to do is go into our header file right here. I'm not going to go ahead and create another code file. I mean, you could if you wanted to, but this is such a small class that I don't really think it needs its own header file. But, some people's coding styles are different. So anyways, we're just going to create a new class, and we're just going to call this noValedictorian exception. And yeah, and this is actually going to inherit from the std exception. Like that, and we're going to have to include the exception header if we want to use that class. All right, and the only thing that we actually have to override is going to be the what method. So we're just going to have to say, I think it returns a constant character pointer. It's just called what, and it's a constant method, and it has this weird throw syntax like that. And then all we have to do is just return a character pointer, which is basically just a string like this of what exception actually occurred. So we're just going to say no valedictorian. And I hate writing out valedictorian, so I'm just going to go ahead and copy it like that. All right, and actually, we'll say student list. Say that to say that this came from the student list class like that. All right, so that's all you have to do to create your own custom exception. And now all that we have to do is just come down here and say throw, and then we just come up with a new. We just had to come up with a new valedictorian exception. So all that we're doing is we're constructing a new valedictorian exception, and then we're just throwing that. All right, and then someone could catch it later on, or maybe they won't catch it, and the program will crash. Whatever. And the other case that we have to look out for here is what if all the students that are in the list are failing? So, I mean, if a student has below a 65 average, we're going to say that they're not a valedictorian. And believe it or not, this is really easy to implement. All we have to say is or students.at0.getGPA is less than 65. All right, so if the student is failing, if the student with the highest GPA is failing, then we're going to say that there's no valedictorian. Or if there are no students, we're also going to say that there's no valedictorian. What happens if the student size is 0? What if there are no students? This is going to crash right here. Well, it won't, and here's why. So first, it's going to check to make sure that the student size is equal to 0. So if the student size is equal to 0, then it's just going to jump right down here and throw this exception. It's not even going to look at this, since this is an OR. Since this is an OR, only one of these statements has to be true, and it guarantees that this one is going to be checked before this expression right here. So as soon as it sees that there are no students, so as soon as it sees that the student.size is equal to 0, it's just going to throw this exception. It's not going to look at this side at all. All right? So that means it's only going to execute this side of code if this is false. So if there are students, so if the student size is not 0, then it will come over here and execute this code. So this will not crash. We're good. I hard-coded this value 65 right in there, and I don't really like that. I don't think it's a good idea to hard-code values like that in there. What we should instead do is come up here and create a define. So we're going to say define, and we're going to define the, we'll call this failing grade as 65. All right, so instead of putting 65 right here, we can just say failing grade. Now, some of you may not be familiar with preprocessor defines. This is kind of what they're called, preprocessor defines. These are actually not variables. So failing grade is not, it's not a variable at all. All that it's saying is everywhere that it sees failing grade, it's going to physically replace failing grade with the value 65. Now we could put anything right there. We could put that right there, and it's going to give us an error because this line of code right here is the exact same thing as putting that right there. There's literally no difference between that. That's why it was giving us an error. So if we undo that change and change this back to 65, then it all will be good. So basically what happens is before your code is even compiled, before your code is even looked at from a compiler standpoint, it goes in here and finds all these defines and replaces everywhere that it sees failing grade with 65. All right? So that's exactly how that works. Just remember that this is not a variable, it's just a define. Okay, so this valedictorian function should work properly right now. There's nothing else that we really need to do, so let's go ahead and test it out. So if we go back to main.cpp right here, we don't want to go through all the students, we just want to get the valedictorian. So we're going to say print student, and then we're going to say list.getValedictorian. Let's run that, and yeah, we get Goody Two Shoes out with a 99.6 average. Okay, so let's go ahead and test the other cases in our get valedictorian thing. So the first case is that there are no students at all inside the list. So we're gonna go ahead and create. I'm gonna actually do it in Sublime right here. I don't know why I have this text edit open. I'm gonna actually quit out of that. But yeah. Anyways, yeah. So here's our student.txt file. I'm gonna go ahead and create a new file just called. Well, actually, there's not gonna be anything in here. I'm just gonna save it as students2.txt. Okay, and then yeah. So now students2.txt has no students in it, so there shouldn't be a valedictorian, right? So if we go back to main.cpp and do students2.txt and run it, we should get an exception. And yeah, so it threw this no valedictorian exception because there were no students in that text file. This check right here failed. All right, so let me just stop that. And instead of not handling this exception, we're going to go ahead and throw a try catch block around this so that we catch our exception and the application doesn't crash. And let's put a catch down here, and we're going to catch an STD exception. So let me just go ahead and include the exception, since we're going to be using that class. All right, so then we're going to say exception, and make sure that you pass it by reference, or else the polymorphism isn't going to work. So just pass this by reference right here, and we'll just call this E, I guess, for exception. And then all that we're going to do is just go ahead and print out onto the screen e.what. And remember, the what function is just going to return a description of the exception. And well, we know that the only exception that it's going to throw, well, I guess we don't know that, but there might be a bug in our code or something like that. But the exception that we think is going to be thrown is the no valedictorian exception. So the string that we should get out onto our screen is this string right here. All right. So let's go back to main.cpp. We call e.what, and then we'll just put an end line right after that. And we're going to actually make this a little bit fancier. So we're going to say an exception was thrown, and end line there, and we're going to put a tab in right here. All right, so now if we run this, yeah, so there we go. Instead of our application crashing, it caught the exception. So as soon as this exception was thrown right here, it just jumped to this catch right here. It jumped out of that code and came down here and just printed out. Oops! It just printed out the exception description or whatever. All right, and the reason that I put a tab there was just to make this look a little bit nicer. I guess some people don't like tabs. I like tabs. All right, so if all the students inside the text file are failing, so we'll go back to Sublime right here, and yeah, so let me go ahead and put Rick Deer, and I think the other person who's failing is Old Greg. Yeah, so all right, we'll just save that now, and if we run it again, we should also get the no valedictorian exception because all the students are failing, so there's no valedictorian. Okay, let's go back to, let's actually change this back to students and just see it work one more time. Yep, works for Goody Two Shoes. All right. So now let's go ahead and implement the other two methods in our student list file. So we need to implement the get honor roll students method. So let's go back to the code file right here and do this. So this is going to return a vector of students who are on honor roll. So we're going to say vector of student, which is a class, and then it's in the student list class. So we do student list : and then get honor roll students. And then right here, I'm just going to create a vector of students and this will be the one that we return. So I'll just call it to return. I like doing it like that. And then we know at the end of the method we're just going to return that vector of students. All right, so what we're going to do now is just go ahead and iterate through all the students and all the ones who have a grade point average above 90. We're going to go ahead and push those onto this vector and then return that vector. Now, the honor roll grade is another magic number, kind of. So instead of just hard coding that number into our program, we're going to go ahead and create another define for it. So I'm going to say define honor roll grade, and that is going to be 90. So if you have a grade above 90, that means you're on the honor roll. Alright, so we're going to use an enhanced for loop again because that's just way easier than using a regular for loop. And yeah, so it's going to be a student, let's call it S, and we are iterating through all the students in our class. Yeah, so if we wanted to, we could say this arrow students, and that would be the same. I'm actually kind of curious why that's not. Maybe I spelled that wrong or something like that. This should be turning red. I don't know, I guess Xcode's just behind, but yeah, so this students vector right here, that is that's this vector right here. Okay, yeah, so basically what we want to say is if the student's GPA is above or equal to the honor roll grade, then we can go ahead and say to return dot pushback S, which is the student. This code will work properly for us. It'll work fine, but there's really no reason to iterate through every single student since we know that this list is in sorted order. So what we can actually do is say the exact opposite. So we'll say if the student's grade is less than the honor roll grade, then we want to break out of the loop. Otherwise, we're just going to, actually I'll put an else here to sort of emphasize that this is an otherwise. Okay, so let me explain this a little bit more. So since the student list is in sorted order, and we're starting at the very beginning, which starts with the students with the highest grade point average. So we're going from students with the highest grade point average to students with the lowest grade point average, and we know they're in sorted order. All right, so if we're starting at the beginning and we keep going down to students with lower and lower GPAs, once we hit one that has a GPA that's below 90, we know that the rest of the students inside of that vector will not have a GPA above 90. Their GPA will be below 90. All right, so that's sort of my logic behind these two lines of code right here. Okay, so let's go ahead and make sure that this works. So we'll go back to our main.cbp file and iterate through them again with the enhanced for loop. Student S in list.get honor roll students, and then we'll just say print student S. All right, so all the students that we print out now should be on the honor roll. Yep, so all these students have a GPA above 90. Perfect. Okay. Now let's go back and implement the last method that we need to, which is the get failing students. All right. So this is going to be a little bit more challenging because, well, you'll see. So we're going to say vector of students, and then we'll say student list since it's in that class, and we'll say get failing students. Again, we're going to create a vector of students to return, which I'll call to return instead of just plain old students. And then at the end of the method, we're going to want to return that. Okay, now the thing that really sucks about this is we're not going to be able to use an enhanced for loop. I mean, we could if we wanted to, but there's really no reason to. That would make it a lot less inefficient. We're looking for students who are failing, so students who are at the end of our vector. If we use an enhanced for loop, we'd be starting at the beginning of our vector. There's no reason to do that. We don't want to iterate through every single student because we just don't have to. That's the reason that we sorted it. So what we're going to want to do is actually start at the end of our vector. And the best way to do that, in my opinion, is to use a reverse iterator. So yeah, so we're going to say In case you don't remember how to use an iterator, we're going to say student, or if you've never used one before, you know, I mean, I don't really use them that much. But anyways, we're going to want to create a reverse iterator, and the syntax for them is kind of wacky. Well, I guess just iterators in general, the syntax for them is pretty weird. But yeah, so we just do vector of students, and we're going to say a reverse iterator. And we'll just call this iter, and we'll set this equal to students, which is that right there, dot r begin. Okay, so you know, there's begin, which points at the beginning of the vector, and there's r begin, which points at the end of the vector. Now, you only use r begin when you're dealing with reverse iterators. If you're using a regular iterator, you wouldn't use r begin instead of end. That just doesn't make any sense. And r begin returns a reverse iterator, so you couldn't anyways. So yeah, r begin just points at the end of the vector, and we want to loop until iter is less than students dot r end, which is the beginning of the vector. And we'll just say iter plus plus, like that. Alright, now I think this is much easier than you know, trying to start at the end of the vector using a regular iterator and then, you know, doing iter minus minus and, you know, stuff like that. I think it's much easier to use this reverse iterator like this. But, you know, to each their own. If you want to do it the other way, go for it. Okay, so now in here, we're gonna use the exact same logic that we did up here for the get honor roll students. So we're gonna say if iter arrow get GPA is greater than yeah, we'll say or equal to. You know, if you have a 65 average, we'll say you're passing. So greater than or equal to failing grade, then we'll break out. So as soon as we come across a student who is not passing, then we can just go ahead and break out. There's no reason to look at the rest of the students because we know that the rest of them will all be passing. All right, and then otherwise, we're just going to go ahead and push that student onto our vector. So we'll say to return dot pushback iter dereferenced. All right, so you may not be familiar with iterators. So if you're not familiar with iterators, let me just kind of talk about this type of syntax right here. So an iterator simply points to a location inside of a collection. You know, you can use them on like std array and anything like that, but we're dealing with vectors right here. So they just point to some element inside of that vector. So if we dereference an iterator, it basically just retrieves the value at that index. And same deal with this arrow operator. So if we wanted to, we could, you know, dereference this iterator and then use the dot syntax like that. But the C++ standard was nice enough to override this arrow operator right here, so we can just treat this iterator like it was a pointer to any other object and just use that arrow syntax. Alright, so that's pretty much it for the failing students, so let's go ahead and test it out. So we'll go back here, and instead of getting the honor roll students, we're going to get the failing students, and go ahead and run that, see what happens. And there we go. So we got old Greg, who has a 49.2, and we got Rick Deere with a 57.2 average. So it only printed out the students with a failing GPA, which is exactly what we wanted. Alright, now to just wrap this up right here and put it all together. So, the first thing that we need to do is print out the students who, well actually no, we want to print out the valedictorian. So, we'll say cout valedictorian, colon, and L, and then we'll say print student list.get valedictorian, and then we're going to want to print out the students who are on honor roll, and I'm going to actually put an end line right there, and you'll see why in a little bit, but trust me, it makes things a little bit nicer. And then we're going to say honor roll students. And then let me just copy this. There's no need to rewrite it. It's pretty much the exact same thing. Get honor roll students, and I'll copy this for the failing students. Yeah, and I did see that error right there, for those of you who were wondering. Yeah, so I think that's all good. Now let's go ahead and run this and see what happens. Something looks wacky here. Oh, I know. I should have put another new line in between valedictorian and this right here, but we can do that in a little bit. But yeah, so we got the valedictorian, goody two shoes, and we got all the honor roll students. Obviously, goody two shoes is well, I guess not obviously, but anyways, goody two shoes is on the honor roll. Bruce Wayne, all them. There we go. There we go. Failing students. Yeah, so the reason that I put a new line right here was so that there were two new lines in between a new category. So we obviously have the new line at the end of the print student function. That just puts an extra new line here. That's why there's an extra new line in between students in the same category, but I wanted there to be two new lines in between new categories. So that's why I threw that extra new line in right there. And it looks like we're also going to want to have another new line in between the name of a category and the beginning of that category with the students. So we're going to throw another new line right there, and right here, and also right there. So let's run this and see how it looks. Yeah, I think that looks better. I don't know, I guess I don't know. I guess it looks weird either way. But anyways, yeah, that's pretty much it. The only other thing that I kind of want to do is talk about arguments. So instead of having this this path hard coded in here, I think it would be better if we were to have the person using this program just pass it in as an argument. So yeah, so what we're going to want to do first is just check to make sure that they actually did pass in an argument. So how do we do that? Well, argc and argv hold all the information that we need to know about arguments. So argc just tells us the number of arguments passed into this program, and argv tells us what those arguments are. So by default, and there's no way you can change this, every time that a program is used, one argument is passed to it, and the argument that is passed to it is the path to that program or the name of the program, depending on how it was run. I don't really want to get into exactly how that works, but anyways, yeah, so there will always be one argument passed into your program. So what we're going to want to do is we want to check to make sure that the user passed in an additional argument. So we're going to say if argc doesn't equal 2, so we're checking to see that the user passed in an argument. If it's not equal to 2, then we're just going to tell them that that's not how you use our program. We're just going to say usage, colon, and then how you use our program. So we're just going to say student information analyzer, and then a space, and then we'll say like path to student file, or something like that. You know, they should get the gist of how that works. Like that, and then we'll just say return -1. And remember that C++ programs do have a return value for main, so you got to return something. And 0 usually indicates that no error occurred, everything worked properly, and -1 indicates that an error did occur and something went wrong here. So we should actually probably put a -1 right there. Yeah, okay, so now what we actually need to do is, instead of using this hard-coded in argument value, we should use the one that the user passes in as an argument. So let me go ahead and copy that, and you'll see why in a little bit. We'll be using that in just a sec. And yes, we're going to construct a std string, and we should actually include that up here. So we're going to say include string. And yes, now we'll say string, and then we'll say, let's call it path, be lazy. And that is just going to be argv at the index of 1, because remember the first argument is the is the name of the program. Okay, and then we just want to pass in path like that. So yeah, in case you didn't know, you can actually convert a character pointer, so like a C string, into an STD string just by passing it through the constructor of an STD string, just like that. Alright, so yeah, now instead of using our hard-coded path in, we're actually just using the path that the user of this program passes in. So let's just run this and see what happens. Yeah, so if we run this right now, it just tells us this. It says usage, student information analyzer, and path to the student file. And remember, this will only happen if we didn't pass in the correct number of arguments, or in our case, we passed in no arguments, so this happened. So there are a couple different ways to pass in arguments. We can just edit some settings in Xcode, which is what we're going to do. But you could also just run this from the command line. And we'll do that later too, so you can see how arguments are used in the real world. So we're just going to go to, I think, product, and then scheme, and then edit scheme to put in some arguments here. And then we'll just go to arguments, the arguments tab right there, and hit plus. We want to add another argument, and we want to add that argument right there. So now if we hit OK and hit run, there we go. So yeah, so now we passed in the path to this text file as an argument, and it worked. All right, so now I'm going to show you actually how you would do it from terminal. So let's say we're using a command line program, and it said, you know, here's how you use it. You just pass these two things in as arguments or whatever, and it runs properly. Well, in case you don't know how to do that, you actually use terminal. And in order to use terminal, we have to know where our program that we just built lives. Or, well, I guess where it is on the computer, not really lives, but, you know, anyways. Before we do that, we're actually going to build it for release mode instead of debug mode. So in case you don't really know the difference, debug mode, it has a bunch of symbols in it. So it has, you know, like the names of functions and their arguments and a bunch of stuff like that. And if people are trying to reverse engineer your program, that would make it really easy for them to do. And well, I mean, I don't know. And it makes your program bigger too. So either way, there's really no reason not to put it in release mode when you release it, when you give it to other people. So to do that, just go back to product, scheme, edit scheme, and go to the build tab up here, I think. Oh no, actually, yeah, my bad. It's under this run student information thing, and then just go to the info tab and change the build configuration to release. And then just hit OK, and go to product build, or I guess you can hit Command B. And there we go. So now we just need to go find that program that it just built for us. So to do that, let me just bring out Finder right here and hit Command Shift G, and then just go to this path right there. Just hit go, and then hit Xcode, derived data, and then I have two. The reason that I have two student information analyzers right here is because a few hours ago I actually wrote the first version of this, just to, you know, kind of figure out exactly how I wanted to lay this program out. And the one that I just wrote now, obviously, is well, actually, I don't know which one it is. It's probably this one. Yeah, just click the one that you have in there, and then go to build products, and then the release one is the one that we want. And then, yeah, so now we just have a program inside of there. And we're going to run it in terminal so that we can actually pass arguments to it. So just go ahead and open up your terminal window. And if you don't have terminal in the bar down here like I do, just go up to Spotlight and search terminal, and it'll come up. Okay, so we want to run this program, so just drag it into terminal like that, and it just puts the path to the application right in terminal for you. And the other thing that we want to give our program as an argument is the student's text file. So just go ahead and drag that into terminal as well, and hit enter, and there you go. So that's how you just pass you know, arguments to programs. You just, you know, put the program path in there, and then you put whatever other arguments you need to pass in there. And you know, remember that each argument is separated by a space. So if I had another argument here, I would just put a space after this string, and then I don't know, whatever argument I need to give it, but our program only takes one argument, so I didn't need to do that. And there we go. So as you can see, that's how our program works. If you want to share it with other people, just distribute this executable right here. And yeah. Okay, and actually one other note before I end this video. I'm going to put all the source code to this program on GitHub, so if you didn't catch a good glimpse of it when we were writing it in this video, you can see it all on GitHub. It'll just be a gist, though. I'm not going to make this a repo or anything, but yeah, so see you guys.